Hello. So in this video we're going to look at an application of the graphs of trigonometric functions. So for a walking person, a leg rotates back and forth relative to the hip socket through an angle theta. The angle theta is measured relative to the vertical and is negative if the leg is behind the vertical and positive if the leg is in front of the vertical. So here's what they're talking about. They're saying this is the vertical right here. And they're looking at this angle theta right there. So if it's behind the vertical, it's negative. It's in front, it's positive. Okay. Measurements of theta are calculated for a particular person taking 1 step per second, where t is in time in seconds, and they look at the results for the first 4 seconds. And they show this in table 1. All right. So again, what two things are changing? So you would basically say, well, okay, what's changing is time and then the angle theta. Now this one's a little interesting because normally theta is your input. In this case, time is your input because the angle depends on what time it is, right? So it takes time to walk, and as you walk, the angle changes. So your input is time, your output is theta. And here, there's the table, and these are the questions they would like you to look at. Verbally describe how you can find the period and amplitude of the, data, not date, data in table 1, and find each. Then which of the equations, theta equal to a cosine of bt or theta equal to a sine of bt, is more suitable for the model. That's for the data in table 1. And then go ahead and find that equation. And then part C, plot the points in table 1 and the graph of the equation found in part 2, in part B. All right, so let's take a look at this. So we're going to look first at part A, of course, find the period and the amplitude. So we want to see, what does it take, how much time, that's our input, how much time does it take to see one complete wave, so that essentially you're getting a repetition, right, after a certain amount of time. Well, we start out at negative 25 degrees, and when is it that we again arrive at negative 25 degrees? Well, not here, not here, not here, here. So basically from here, 0 to 2 seconds, right, we see that we then get a repetition. So the period is 2 seconds, okay? And then, so let's go ahead and write that down. For A, the period is 2 seconds. Okay. And then they also ask for the amplitude. So basically we go from negative 25, then through 0 to positive 25, and we never go beyond, lower than negative 25 or above 25. So we can see this is going to be around the axis of 0. We're going to go to a max of 25 degrees and a min of 25 degrees. So we're going to see that our amplitude then, all right, is going to be 25 degrees. Okay. Now, let's go ahead and graph this because I think it's going to give us a lot better idea of what's going on. So let me go ahead and start up a graph. Now, so in my graph then, right, I'm going to graph time, and here theta, right, which is a little bit unusual. We're going to go from negative 25 degrees to positive 25 degrees, right? And we're going to start here at 0, and our data values go all the way to 4. So let me go ahead and give us our 4. And now let's just start dividing this. So at, let's say, 2, and then here 3, and here 1. I'm not sure these are equal, but I'm trying. So then we have a half, and then 1.5, and then 2.5, and 3.5. Okay, so if I start at least just putting points where I see, so I can plot the point at 0 seconds, I have negative 25 degrees. So I'll go ahead and do that in red. I'd be here. And then at half a second here, so half a second, I'm at 0 degrees. So I'm here. And then at 1 second, I'm at 25 degrees here. And then finally at 1.5, I'm back to 0. And at 2, I'm back at 25 degrees. So we can see already one wave of what this looks like. Right. And it looks kind of like a bell already, right? So then we're going to continue this. So this is going to go here, 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 and finally here. So here's... So I know I think they asked this to plot the points as part C, but it sure helps, I think, visually to go ahead and do it before you get there. That way you can kind of see what's the equation. I'm very visual, so when they're asking in part B, which equation should I use, now I can really tell because, so here I'm working on part B. Well, remember a sine wave, the basic shape of sine is to basically start at the axis and then go up to a max, come back to the axis, go to the negative min, and then go back to the axis. Whereas for cosine, the basic shape is to do this, right? Here's the axis. You start already at a max, then you go to the axis, a min, the axis, and a max. So this looks a lot more like a cosine wave, except that it's what? It's reflected, right? So this is what it looks like. And it starts at the min, goes to the axis. Sorry, this should be a little bit more symmetric here. Here, comes back. So really what we have here is a reflected cosine wave. We can see that. So when they ask which of the equations is more suitable, it's definitely, sorry about the shaking, A cosine BT, right? So we want to use for B, we want to use theta equal A cosine BT. Now we already know that here it's reflected, and we know that we found out in part A that the amplitude was 25 degrees. So we now know that A itself is negative 25 degrees because it's a reflected cosine. So we know that. And now we got to find this right here. What is B? So we know that it takes for a period, right? We found that we want to do 2 pi over B, and we know that it took 2 seconds to see one wave. So we know the period is 2 seconds. And we know that 2 pi over B should be our period. Right? So 2 pi over B is 2 seconds. Right? So now if I multiply both sides by B, I'll get 2 pi equals 2B, understood 2 seconds B. And now if I solve for B, I'll have 2 pi divided by 2, which is just pi. So now I have B also. So now my equation then, right, is, I like to separate stuff, theta equal to A cosine BT. Now I just got to fill it out. Theta equals A, which is negative 25 degrees, cosine, and B is pi t. That's our equation. Okay. So there we are. We've got that part. And let's see if we've already done C. Plot the points, which I did. All right. I think that's it. All right. Thanks so much for listening. If you want to test this, what you could do, I think this is part of C, is you might want to put in, for example, at 0, cosine of 0 pi is the same thing as cosine of 0, and therefore you'll have the cosine of 0 is 1. So 1 times negative 25 is negative 25. And you can keep doing this, just putting in values and seeing if you're getting the same outputs. Is this equation correct? It is, but it'd be nice to do a check on it. All right, thanks so much for listening. And I just wanted to make a point here, sorry, before I'm done. See, this is the kind of cool stuff, like if you're going to be a physical therapist, right? You got to know angles. You got to know, is this person, what's their range of motion, and that kind of thing. So this is all part of an application of trig. Thanks so much for listening.